Yes, here, yesterday what we discussed in Nana, to find out the capacity. First of all, we have to see what is the breaking strength of surrounding media. Okay. For the surrounding media, what I said, Nana, the breaking strength is nothing but the field intensity E on the surface of a conductor. Okay. If the breaking strength of surrounding medium is equal to E on the surface of conductor, then yesterday we concluded that the charge what you are giving to the conductor that tries to leak into the air. Am I right? So here we concluded that you can give the charge to some extent on the surface of conductor. Further, you can't increase the charge on the surface. Okay. So Q will be increased on the surface of a conductor. Okay. Why? Because we are taking conductors now. For the conductors, the charge resides only on the surface. Okay, it won't enter into. So the charge will be increased on the surface of a conductor to certain value only. Okay, means to some maximum value. Further, if the charge is okay, if the charge is added, then what happens? Here, what I said that if charge is added, then it will leaks into the surrounding. Okay. So if you want to increase, we understood from this concept what to increase. Okay. To increase the charge, we have to change the surrounding medium. Okay. If you change the surrounding medium, then charge will be increased or decreased depending upon the strength of the surrounding medium. Okay, good. Then here, suppose it is one conductor, okay, of radius r. Okay. If they ask one question related to this concept, what is the maximum charge that you can give to particularly the spherical conductor? Is in this case, to the spherical conductor, if it is placed, okay, the sphere is placed in the medium air. Okay. So, not for all media, particularly for air, we have to come to know what is the breaking strength. Why? Because while solving the numericals or doing the experiments, generally we do the experiments in air. Okay. That's why for air or vacuum, not for all media, the breaking strength we have to come to know. Okay. Then what will be the breaking strength of medium? That is air. So the breaking strength B of air, okay, they found it is equals to 3 into 10 power 6 volt per meter. Okay. Volt per meter means it is what on actually? The electric field intensity. So what he is saying indirectly here, sir, if you try to increase the field intensity on the surface of sphere up to 3 into 10 power 6, okay, no problem, sir. The charge will reside on the surface without leaking into the surrounding heat. But if you increase the field intensity, means if E on the surface is greater than 3 into 10 power 6, okay, volt per meter, then the charge added will be leaked out. Okay. So here, what is the maximum field intensity that you can give on the surface is equals to, that's what I told you, equals to breaking strength. So breaking strength of here in this problem, what he said, this is the solution, what I am writing here. E on the surface is equals to the breaking strength, which is equals to, he gave for air or vacuum, 3 into 10 power 6. So what he asked previously in exam, find out the maximum charge that you can give to a sphere of radius. Actually, in exam, he asked to a sphere of radius 1 millimeter. This is the exact question what he asked. Okay. In this case, radius he gave, which is equals to 1 millimeter means 10 power minus 3 meter. And you know the E on the surface, and we know the field intensity on the surface of particularly sphere. The formula is 1 by 4 pi epsilon naught q by r square, which is equals to the breaking strength, which is 3 into 10 power 6. Okay. Then what he is asking here now, just to find out what is q max. Okay. Simple. We are going to substitute whatever the information given to us. So here I am going to substitute 1 by 4 pi epsilon naught, that is 9 into 10 power 9 into q. He is asking what is the q max divided by r square. R square is 10 power minus 3 whole square, which is 10 power minus 6. Okay. Then here, which is equals to, on the right hand side, we have 3 into 10 power 6. So if you cancel 3 times, and 10 power 6 if you cancel, it becomes 10 power 3. So 3 into 10 power 3 into q max by 10 power minus 6 equals to 1 watt. Therefore, just to rearrange the terms, q max is equals to 10 power minus 6 divided by 3 into 10 power 3. That is 1 by 3 into 10 power minus 9 altogether by taking the 10 power plus 3 to the numerator, and which is equals to 0.33. 10 power minus 9 is nano coulomb. Okay. This is the Q max that you can give to whom a small sphere of just radius 1 millimeter, very small. Okay, for that you can add a charge of 0.33 nanocoulomb at max without leaking the charge on the surface, from the surface. Understood, Nana? So here what I am asking, suppose this is one charged plate. Okay, and I am not changing the surrounding medium, right? So if that field intensity on the charged plate is greater than 3 into 10 power 6, then what happens? All of it, the charge leaks, okay, into air. So what the concept previously here from the erased part we discussed, if you want to increase the charge, we have to change the surrounding medium. Okay. But here I am not interested to change the surrounding medium, keeping the medium as air only. Okay. But I want to increase the charge on this surface without leaking. Okay. logically think, Nana, this is air. Okay, it has some restrictions. What it sees all the times whether the field intensity is greater than 3 into 10 power 6, my breaking strength, mine is 8, breaking strength or not. Okay. If the field intensity is less than 3 into 10 power 6, happily it won't behave as what, Anna? The conductor. Okay, it behaves as insulating medium only. Okay, that point also yesterday I discussed, Nana. If E is greater than 3 into 10 power 6, the insulating medium behaves as a conductor. That what happened, I explained yesterday, the lightning of charge means the charge leaking into air, the lightning concept from the flux. Okay, so here, if it is a conductor, okay, logically I am thinking that if I change the field intensity, then I may give more amount of charge to the surface. Why? Because sigma is equals to formula is Q by A. Okay. Whereas sigma by 2 epsilon naught, that is equals to Q by 2A epsilon naught. I am not changing the medium epsilon naught. I am not changing the area. Okay. So here I want to increase the charge. Okay. Then what you do, sir? Okay. For that concept, what he is saying, by giving the charge to it, what the disadvantage we found? The field intensity, which is E is equals to sigma by 2 epsilon naught, which is Q by A into 2 epsilon naught. Okay. This waste fellow is directly depending upon the charge. Okay. If I increase the charge, it is also increased, reaching the breaking strength and charge started leaking. Okay. So what I am doing, it is completely related to the field intensity. Why? Because he is believing the field intensity. Okay. So what I am going to do, I want to change the field intensity. Nothing but field intensity is dou V by dou X now, minus dou V by dou X. So I am going to change the potential. By that I am going to change the field intensity. By that I can change the charge. Okay. So that logic I am following here. Okay. Then here I am doing one experiment. How to change the potential on this plate to change the field intensity. Okay. So here, suppose this is one charged plate A, and it is the maximum charge that I gave to the plate. Further, I can't increase the charge. Okay. So here what I am doing, I place one neutral plate. Means initially Q initially equals to 0 on this plate. Okay. Then what happens if it is close to the plate A? All of you know one concept, not in contact means, since it is also a conducting plate, both are conductors, Nana. Immediately by the method of induction, something happens here. What is the method of induction, sir? The positive charge here tries to induce, since it is a conductor, equal amount of negative charge on the nearer face. And since it is a chargeless body, initially the charge is 0. So on the other side, equal amount of positive charge will be induced. Okay. By that, what happens? Here, look at Nana. This negative charge is close to the plate A. Okay. Since it is close to the plate A, it tries to induce some negative potential on this surface. Okay, means what I'm calculating the potential of A due to the self charge plus potential due to this negative plus potential due to this positive. Okay, what is the potential nearer to this surface? I'm finding out. Okay, look at Nana, negative is close to the surface. Close means potential will be more. Here, potential will be more means to understand, assume few values here Nana. What's okay? The values VA, suppose 5 volts. Okay, since negative charge is close to this positive plate, I assume the negative potential by the negative charge. There's some minus 2 volts. Okay. And then here look at a positive plate is not close, a bit far away. Bit far away means the potential will be less and it will be positive due to the positive charge. Wait, please. Positive charge. And here that potential, let it be 1. Okay, understood the concept here, Nana? Previously, if you won't place the plate B, there is only one potential, that is 5 volts. Okay. By this, you are getting an electric field intensity of 3 into 10 power 6. Just an assumption. Okay. Some value I'm assuming here. Right? And then here, what I am saying, if you place the chargeless plate B, then by the method of induction, some charge and charge, unlike and like. Okay, positive, 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 negative. Unlike charge, like charge, and they are induced on the sides. Okay, here if you see to the 5 volts, now additionally we are getting some potential due to the negative. Okay, since it is close, I'm assuming a bit bigger value compared to the other. This is minus 2 volts. And due to the positive, at the same point, I'm going to get 1 volt. Okay, this is my assumption. Why I'm assuming lesser value here compared to the 2 volts? Because it is bit far away. Distance is more, potential is less. Okay. Then here, if you add, I'm getting 5 minus 2, 3, 3 plus 1, 4 volts. Potential is decreased now. Potential is decreased means, look at this concept. If potential is decreased according to the formula of minus dou V by dou X. Okay. I'm not changing the distance now. So it is constant. And here, this potential is decreased. Is decreased means what happens? Immediately the electric field strength formed by this plate will be decreased. Is decreased means previously how much is the value, Nana? By giving the maximum charge, you have 3 into 10 power 6. Okay. Now the field intensity is decreased means, suppose it is decreased to say some 2 into 10 power 6. Okay. Then the charge won't leak into air. Okay. That's why again to increase this value to the breaking strength of surrounding medium, which is 3 into 10 power 6. Okay. To increase whom, Nana? The decreased E. Okay, the decreased E, this is decreased value of E. Okay, to increase this value to, okay, to increase the decreased E, the charge on A to be increased. Okay, I will explain this point again. Here the field intensity is suppose 3 into 10 power 6 volt per meter. The charge which is given to the plate A will be lit. Okay. So here my disadvantage, if I won't place the plate B here, okay, I can't increase the charge more than this Q max. Okay, Q max means I assume some value. I can't increase more than say some 2 microcoulomb. Okay, so what I am doing, I am not changing the plate, I am not changing the surrounding medium, means again the breaking strength is 3 into 10 power 6. Just I place another plate B. By this, of course, some induction process happened, and by that potential here is decreased. By that electric field strength is decreased. So here now the potential electric field strength is not 3 into 10 power 6. It is 2 into 10 power 6. Say some example. Okay. So now you only assume, Nana, you add the charge to this plate till the field intensity here raises to 3 into 10 power 6 or not? Okay. So to increase this value 2 into 10 power 6 to the value breaking strength 3 into 10 power 6. Okay. How can it be increased, Nana? By increasing the charge. That's why I'm increasing on increasing the charge on the plate A. Okay. So on the plate A, now to increase the value, here I am adding some amount of charge Q. Okay. After adding this amount of charge, suppose the field intensity is increased to 10 power 3 into 10 power 6. Again, further you can't do anything now. Why? Because again, if you add the charge leaks. But observe here, I got one advantage. Previously, if I take the isolated plate, I gave only Q max. But now, if you put it here near another plate, okay, I'm able to add some amount of charge to the same plate. Okay, means here, suppose your capacity is plate meals. Okay, to have full means, what we do immediately, we try to change the belt size. Okay, and we loosen our fan and we try to increase the quantity of food that what we take. Okay, here same thing happened now. Isolated is not taking more charge. That's why what we are doing, placing another plate. By that, some amount of charge is increased. Look at here, it is taking more amount of charge here without changing the surrounding medium, without changing here the dimensions of the plate A, without changing the dimensions and without changing what the surrounding medium. I increased the charge from Q max to Q max plus Q just by placing another plate B, neutral plate. Okay, this is the way of increasing the capacity of the plate A. Okay, I think now you understood what is meant by capacity. Capacity is a physical quantity up to which it can take the charge. Okay, that is called as capacity, right? That capacity, further I want to increase now, means still I am not satisfied with this belt size. Okay, again I want to loosen my fan. Okay, here how to again increase the capacity, means increase the charge that it can take. For that, what I am doing, logically think, if there is no plus 1 volt, then the potential would have been decreased to not 4, actually 3. If the potential is less, then I can increase further more amount of charge or not. That logic I am following here. Okay. So here, if there is no positive charge on the other side, okay, suppose the self potential, I assume some value, say some 6 volts. Due to the negative, you are getting, say, some 3 volts. Due to positive, say, you are getting some plus 1.5 volt. Okay. This plus 1.5, I don't want. Okay. For that, what to do? You have to remove this charge. You have to remove means you can't erase like the positive values here on the board. Okay. It is not the erasing concept. So how to remove that positive charge here from the plate? For that, here, what he is doing, it is connected to the very good conductor naturally given by the God, the earth. Okay. Yesterday I told, whatever the charge leaks from the clouds, that will immediately tries to go towards the earth. Why? Because earth is a very good conductor. Okay. So here, that earth symbol I am drawing like this one. It is called as earthing. Okay. So here what I say, the farther side of plate B is earthed. Okay. Means is earthed means what? Connected to the earth. By whom? Just with one wire. Okay. Just like what we do to send the excess amount of charge in the apartments or buildings. What we do, Nana? Just we connect the third pin, 0th pin of the all plex. We connect it to the earth. Okay, that is called as earthing, process of earthing. Okay, here that is earthed. Then what happens, sir? The excess positive charge on the plate B will try to go to the earth. Okay, why, sir? Because yesterday I told earth is a very big conductor, huge in size. That's why whatever the amount of charge you are giving to the earth, whatever the amount of charge you are taking from the earth is just peanuts now. Just like adding a bucket of water to the ocean or removing a bucket of water from the ocean. Okay. So there, if you add one bucket of water or one bucket, if you remove one bucket of water from the ocean level won't change. Okay. Because of what? Just because of its huge size. Suppose from a bucket, if you remove one mug of water, then the size of water in the bucket will be changed. Okay. Here, that is the advantage. I connected it to not other conductor to the earth, huge in size. That's why whatever the charge you are giving to the earth, after taking, the earth nature won't be changed. The earth always behaves as a neutral body. Neutral body means no charge, no potential. That's why always we take the concept that the potential on the earth is 0. Okay. So if the farther side is connected to the earth, what happens? Earth is at 0 potential. That's why it takes the charge until the potential on the farther side equals to 0. Okay. Farther side potential will be 0 when, Nana? When this total charge flows to the earth. Okay. That's why after connecting, what happened? To make the potential on the farther side 0, that charge flows to the earth. Charge is flowing means logically think negative charge is added to the plate. Okay. So that plus and this minus coming from the earth all nullified here and total charge became 0. So the advantage what I got here now previously plus 1.5 is there. Okay. So actually I should get how much Nana? 4.5. But now I am getting how much Nana? 6. minus 3, and this value becomes 0. Okay. Now I'm getting how much? 3 volts. Okay. Oh, we decreased the potential on the surface of plate A from 6 to 3. Lot of decrease we are seeing here. If potential is decreased, field intensity is decreased. Again, same concept. Field intensity suppose decreased to. If E is decreased to, say, some 1.2 into 10 power 6 volt per meter, okay, so taking some value, then we have lot of advantage. Again, you can increase this value to, you can increase this value to the breaking strength 3 into 10 power 6 volt per meter. How can you increase the value to 3 into 10 power 6? How can you increase the value of E? By increasing the charge. Okay. So again, I'm going to add to this some more amount of charge. Okay. So here, initially the isolated one is only this much capacity to take the charge. After placing the plate, neutral plate, this much capacity it has to take the charge. Now the farther side is earthed. Again, this is the capacity of the combination to take the charge. So finally, the capacity to take the charge is increased or not? Yes. So isolated plates or bodies, conductors, I can say they can take the charge to certain value only. So my conclusion is have less capacity to take the charge, but okay, a system of conductors. Okay, system of conductors means here how many conductors I took, Nana? 2 conductors. System of conductors have more capacity to take the charge. And again, in that system of capacitors, if the farther side is earthed further, if the farther side is earthed, then the capacity is maximum. Okay, is increased. Okay, that's why here out of the 3 combinations, means out of the 3 sets here, which one you prefer to give the charges are? I prefer always this type of conductor. Means conductor, neutral conductor, farther side is earth. Okay, this type I prefer. And here in this case, what you took, Nana? 2 plates. Okay, in the theory, 2 plates, and those 2 plates are kept parallel to each other. That's why this combination is called as parallel plate capacitor. Okay, this is called what? Parallel plate capacitor. Okay, this is the story of increasing the capacity of a conductor. Okay, where it is good to take the charge, isolated or system. I explained here now. Okay, in this concept, if you have any doubt, you can ask now. Here, in this case, particularly, I am not interested to take the isolated conductors. I am interested to take the combination of conductors. Okay. Before starting the combinations here, Nana, suppose when you come to exam point of view here, suppose means in exam what they ask, the potential at a point due to the plate and due to the line of charge, infinite line of charge, the potential at a point is undefined. We previously discussed. Okay. So here, generally, when you come to exam point of view, they focus more on spheres. So if you take isolated spherical conductor of radius r. Okay. First, we try to finish the isolated part, then we can enter into the combination. Right? For this conductor, if they ask what is Q max when it is placed in air, I already discussed. What is its capacity to take the charge? Okay, capacity. Suppose if you represent with the letter C, how much? Okay. For that, what he is saying here, suppose the potential on the surface of a conductor. Okay. Try to focus more how to find out the capacity method. On that method, you try to focus more on. Anyway, you have to do the same procedure. Means go through the same procedure. Okay. Here, if you don't know the potential at a point, okay, generally we go through the formula E is equals to minus dou V by dou X. Okay. From this, we have to find out the potential according to the formula minus integral E dot dx or dr, anything you can. Okay. Limits, I think you remember, final to initial. First of all, you have to find out the potential with the help of field intensity. Okay. So here, to start the concept of finding out the capacity, first of all, you have to come to know the field. Later, you have to come to know the potential. Luckily here for the spherical conductor using this formula, previously we calculated the potential according to the formula. We know that, but here no need to use this formula. Directly we know it. We know V on the surface of spherical conductor is 1 by 4 pi epsilon Q by R. Okay, this is our formula. In this formula, here, until you reach the value of Q max, okay, I'm not changing the size of conductor. That's what I explained previously here, there, and all cases I explained. I'm not interested to change the dimensions of the plate A. I'm not interested to change the medium, but I want to increase the capacity. Okay, that how I did here. Same way, here I'm not interested to change the dimensions, means I'm not interested to change the radius. So R, I'm keeping constant. Okay, 4 pi epsilon naught, they are constants. So here what happened previously in all cases, the Q, if you increase, the V is increased. Why? Because they are directly proportional. The rest of the things are constants. So basically, he is coming to the concept of, means in any derivation we are coming to. Okay. Once again, I am repeating, we are not at all interested to change the dimensions. Okay. We are not interested to change the surrounding medium. These two we are not interested. Okay. So you can increase the charge up to Q max. By that, the potential on the surface will be increased. So basic concept here you are getting that Q is suppose increased, V will be increased. So Q is directly proportional to V. Keep in mind, V is not directly proportional to Q. Q is directly proportional to V. Okay, right. Means it is just like student and master number. Okay. Right? Here the V is student, Q is the master. Right? So V depends upon the Q. Student depends upon the master, not the master on student. Okay. So Q is directly proportional to V. That implies you can write this formula as Q is equals to some proportionality constant into V. That proportionality constant I represent with the letter C, which is called as the capacity. It is the basic concept now. Okay. This part is the basic concept. Okay. So here you look at in the basic concept, you came to know one new physical quantity, that is capacity. Okay. So capacity of a conductor, or its other name is condenser, anyone you take. Okay. Capacity of a spherical conductor or conductor. C is the capacity. Okay, already I wrote. That C, while giving the charge, you can write according to the formula Q by V. Am I right? So here, that Q by V means immediately first we write what is its unit. Its unit will be, okay, here Q by V. Q unit is what, Nana? Coulomb by V unit is volt. Okay, represent with the letter V. So Coulomb per volt. That is actually the unit of capacity. So here Coulomb per volt actually found by the scientist Farad, not Faraday. It is chemistry unit. So Farad, scientist name. Okay. So the capacity unit we are taking it as Farad. So 1 farad is equals to, I write according to the formula, 1 coulomb per 1 volt. Okay. So 1 farad is equal to 1 coulomb per volt. Right? So when you come to numericals, we are giving the respect to the scientist, represent with the unit of farad, not coulomb per volt. Okay. So this is the final unit of capacity, represented with the letter F only. Okay. And what will be its dimensional formula, sir? Dimensional formula. Q dimension formula is IT. And V dimension formula, I think all of you forgot. Okay. So here I write that V from the formula V into Q. W is equals to V into Q. So V is equals to W by Q. Okay, which is M, W is L square T power minus 2 energy dimension. By Q is IT or AT, anyone you can use, I or A. So here if you substitute capacity dimensional formula, what you get? C is equals to Q, that is IT, by ML square T power minus 2 by IT. Okay, W by Q. So I'm getting here, this is M power minus 1, L power minus 2, T square. Okay, this IT, if you bring it to the numerator, you will get I square into T square. This IT is multiplied with the given other IT. So capacity dimension formula, I'm getting M power minus 1, L power minus 2, T power 4, I square. This is the dimension formula of capacity. Okay. And here there is no doubt at all. Why? Because Q is a scalar, potential is a scalar. Scalar by scalar always gives a scalar. So capacity is a scalar. Okay. So fundamental things I explained here. Basic things. Okay. Now coming back to my example, I asked there what is the capacity of the spherical conductor? That is my question. Okay. So coming back to the solution here, what is the capacity? Look at the formula, Nana. We know the formula of potential on the surface here equals to what, Nana? 1 by 4 pi epsilon naught Q by R. Okay. Whereas to find out the capacity, anywhere we use this basic formula. So in place of V, I try to substitute this value. Therefore, here I write, okay, here I write Q equals to C into the V for spherical capacitor, spherical conductor, I got 1 by 4 pi epsilon naught into Q by R. Look at now here, Q get cancelled. And this denominator term 4 pi epsilon naught R, if you bring to the left hand side, then you will get 4 pi epsilon naught R cross multiplication equals to C. This is the capacity of spherical conductor. Okay. So look at here, capacity of spherical conductor. Okay. Look at the formula, Nana. The capacity once again, it is depending upon whom. Okay. The capacity is equals to 4 pi constants. Okay, leave them. Epsilon naught depending upon the surrounding medium into R depending upon the dimensions. So you can conclude here C depends on the surrounding medium, what we discussed in the theory previously on the surrounding medium, and the dimensions. Okay, dimensions is what are the sizes, like radius, area, volume, like. Okay, it depends upon the dimensions. So here the student may go to one misconception. Okay, what sir? Sir, capacity is equals to Q by V. Okay. Whereas you are telling that capacity is equals to 4 pi epsilon naught R for the spherical conductor and depending upon only the surrounding medium and radius. Okay. So according to this formula, can I say capacity depends on charge and potential, sir? Okay. Then I think if you think wisely, you will get the idea here. Capacity in the derivation, look at Nana, it is the proportionality constant. Okay. Here, suppose Q is doubled, the potential also will be doubled according to the formula. Why? Because they are directly proportional. Okay. Again, the capacity will be same. Suppose Q becomes 2 times. Then according to the formula, potential also will be made 2 times. So again, 2 cancel here. You are getting the same capacity. That's why you only think it is not depending upon the charge and potential. Okay. So here I say C is, okay, I write here. C is independent of the charge on the capacitor and the potential on its surface. Okay, right? And it is actually what, sir? It is the capacity to take the maximum amount of charge, okay, from some outer sources. So C is the capacity of what? To take maximum amount of charge. Okay. So don't argue, sir, I am taking one neutral spherical conductor, sir. Here, means I am not giving any charge to this here. I am not giving any charge means Q equals to 0, sir. Okay. So if I put Q is equals to 0, I'm going to get capacity is equals to 0. So if it is the empty conductor means chargeless conductor. If it is chargeless conductor, can I say its capacity is 0, sir? Then immediately I will ask one question here. Now you are taking one glass, okay, irrespective of nature of material. Depending upon your wealthiness, you may take gold glass or silver glass also. Okay. So here, suppose this is one glass nana and it is empty, not filled with any amount of liquid or water. Not filled with any liquid means here, can you say its capacity to take the amount of water 0? So I think you understood. Whether it is empty or filled with liquid, okay, its capacity is not equal to 0. Its capacity is, it can take the liquid up to its brim, whether you fill with liquid or not. That's why don't say if the charge is 0, the capacity of the conductor is 0. Okay. So I think from this explanation you understood the capacity is basically depending upon who? Depending upon the dimensions. Okay. And that capacity gives the maximum amount of water that it can take in case of glass. In the same way, here it gives the maximum amount of charge that it can take. Understood, Nana? So while coming to the numericals, don't get confused. They surely confuse you while solving the problems. I'm taking one chargeless capacitor. If they say, immediately don't put C is equals to 0. Okay. So try to understand chargeless capacitor means the capacity of chargeless capacitor is, don't say not equal to 0. Then what can we write, sir? Chargeless means you can write Q equals to 0. So capacity of chargeless capacitor is again how much, sir? If it is a spherical conductor, it is 4 pi epsilon naught R. Sir, if I take charged spherical conductor, sir, I give some amount of charge to it. What is its capacity, sir? Again say 1 by 4, 4 pi epsilon naught R. Okay. Here my question is, suppose it is not filled with water. What is the capacity of this glass, Nana? Say suppose some 2 liters. Okay. If it is filled with the liquid, then what is its capacity? Whether it is filled with the liquid or empty, its capacity to take the liquid is 2 liters of it. Okay. Same explanation I gave here. Whether it is charged or not, its capacity will be same for the spherical capacitor, 4 pi epsilon naught R. Okay, good. If it is charged, then you will come to know the value of Q. You will come to know the value of potential. Then you can use this formula. Okay. So when you use this formula to find out the capacity, when it is charged. Okay. Otherwise, whether it is charged or not, we use the fundamental formula for a spherical conductor. Here, any doubts in this concept, Nana?
No, sir.
Right. Will you take the points from the book? Nana? Now we start the combination of like what we discussed, parallel plate capacitor, okay, or spherical conductors. This part is very important for us, exam point of view, right? Entering into the combination, right? And here, suppose first if I take the parallel plate combination, okay, these are 2 parallel plates, say A and B, right, of same size. Okay, same size means length is same, area of cross section is same, everything. Means suppose this is the plate, like the rectangular plate, the length will be same, breadth will be same. Okay, same sized. So here, in this case, first of all, I am not earthing the farther side. Okay, and I am giving some amount of charge to only one of the plates. Say, let it be some Q1. Okay, means I am taking Q2 equals to 0. Then what happens, sir? Okay. Here the question is, these are the plates, conductors. Conductors means, suppose if you consider, even though the size is small, okay, take the zoom, okay, not in the app, by increasing the size, okay, in the picture, by zooming the picture like this. Here, this is one thin plate, okay, plate A, and here also, this is plate B, okay. Then the charge on this one is called Q1. My question here is, this charge resides only on the surface. Actually, how many surfaces are there for this supposed plate? If you take 1, 2, and then top, and then bottom. Okay, actually these two. Altogether, 6 sides are there. But we are taking thin, means the size of this part is less. Thin plate means the charge on the top, at the bottom, at the sides are negligible, since it is a thin plate. Okay. Then here, if you come to the concept, I'm going to find out by neglecting these sizes here and there, only front and back I'm seeing here. The charge on this side, let it be Q. Okay. Whereas the total charge on the plate A is Q1. So the charge on the other side, you can assume it as Q1 minus Q. Why? Because altogether the charge should be Q1. By adding these two, you should get Q1. Okay. That's why here the charge on the other side will be Q1 minus Q. Okay. Here it is 0 now, right? But by the method of induction, what happens? This plus Q will induce exactly minus Q here. And I took Q2 equals to 0. Means the charge on both sides, by adding, I should get 0. So the charge on the other side, easily I can assume it will be plus Q. Okay. Altogether, I am getting it is 0. Right? So here, these are the charges called the charge distribution on the 4 sides of the 2 plates. Okay, 1, 2, 3, 4 on the 4 sides. Okay. So here, what is the value of Q if you are able to find out? Okay. Simple observe here, you can say the charges on 4 sides. Very easy. So here what I am going to do, what is the charge on this side, small q equals to how much? Okay. For that I am following one simple logic, Nana. Since these are conducting plates, the electric field intensity inside the plate A or inside the plate B, okay, means at the points X and Y, okay, E at X is equals to E at Y equals to, I say, 0. Why? Because there are what the conducting plates. Conducting plates inside the field intensity is 0. What we discussed previously. Okay. So here I am going to use that concept. Okay. Anyone, either at X or Y. Okay. Suppose here I am going to find out what is the field intensity at Y, which is equals to 0, is by the 4 charges, how much you are going to get. Okay. For that, since I am taking them as plates, okay, the field intensity due to a charged plate is equals to, I know the formula, E due to a charged plate by the charge on the side is sigma by 2 epsilon naught. That is my formula. Okay. Where sigma is equals to, again, formula is Q by A. So Q by A into 2 epsilon naught I am going to use. Okay. So here, according to that formula, first of all, I'm going to take all the four charges, the field intensities, not charges, the four field intensities. Since it is a vector, I have to add them include by taking the direction also. Okay. So I am going to take here E1 plus E2 plus E3 plus E4. Okay. So look at Nana, I am taking the point Y here. Okay. The same thing I am drawing there. Right. First, I'm going to find out what is the field intensity due to the first. Okay. This is positive plate. That's why these two charges are positive charges. So due to the positive charge, the field intensity at a point will be away from the charge. Away from this charge means you will get towards the right. So it is the direction of E1. Okay. That E1 magnitude I am writing here according to the formula. Q by A into 2 epsilon naught. That Q is how much you are getting here, Nana? Q1 minus Q. Okay, it is the charge. Charge by 2A epsilon. Okay, right. Next E2. Look at this one, Nana. This is the second one. And the charge, already I told it is a positive charge, means both are positive. So it is also a positive charge. Positive means away from this positive. From this positive, away means you will get E2 also towards the right. Okay. So its magnitude I am writing here now. Again by A into 2 epsilon naught. And the charge is here not Q minus Q, it is Q. Okay. So the charge I am taking here Q. This is the magnitude. Right? And look at to the third surface now. It is negative charge. Okay. Negative charge is here. This is the third side. Okay. And the point is on the other side. It is negative and point is here. So at the point Y, the electric field should be towards the negative charge. Towards means you are getting towards left here at the point Y. This is E3 due to the negative charge. So here, if I write the magnitude E3 equals to by A into 2 epsilon, that's what I told Nana. I'm writing the same dimensions here. AC. That's why initially I told their areas are equal. Their dimensions are equal. Okay. So here I am substituting the same area in the formula. And the charge is minus Q, but you are writing the magnitude. Magnitude means mod minus Q. Okay, that is plus Q. And finally, you are coming to E4. Okay, first I write the magnitude by A into 2 epsilon naught, and the charge is plus Q. So no problem. I write here straight away Q. Okay. And here look at Nana. This is plus Q at, but the point is towards left. Okay. So here at the point, due to the positive charge, okay, due to the positive charge, away from the charge, away from this charge will be towards left. Okay. So away from the positive charge, fourth side, away from the positive charge, I will get towards left. This is E4. Okay. So here, these are the charges I'm finding out, Nana. Total should be equal to 0. Okay. So including the direction by taking the right hand side as positive and left hand side as negative, I'm writing here, substituting here, E at Y, which is equals to 0 equals to E1 towards right. So it is positive. Q1 minus Q by 2A epsilon naught. Okay. Plus E2, that is also towards right. So positive plus Q by 2A epsilon naught. E3 and E4 are negative, Nana. Why? Because they are towards left. So minus E3 is mod minus Q is Q by 2A epsilon naught. And the last one, E4 towards left minus Q by 2A epsilon naught. Okay. Look at here, Nana, by taking 2A epsilon naught as LCM and cross multiplying with 0, Okay, you will get left hand side 0, 0 equals to, you will get here 0 equals to q1 minus q followed by plus q followed by minus q and then followed by minus q. Common already by 2a epsilon naught is cross multiplied with the 0. Okay. So here altogether what you are getting, this minus q and plus q get cancelled. I am getting 0 is equals to q1 minus 2q. Okay. So that implies 2q is equals to q1. Therefore, q is equals to q1 by 2. Okay. So it is q1 by 2 at. Now I am writing the distribution here. Okay, it's already 11:30 now, coming to the end. Here, the charge distribution I am writing q is q1 by 2. Other side q1 minus q, that is q1 minus q is q1 by 2. That equals to how much, Nana, you will get here? That is half q1. That is q1 by 2. Okay. And then here it is minus q. This is minus q1 by 2. And for that side you are getting plus q1 by 2. Okay. And here my intention is, look at, Nana, try to remember it as a shortcut. Look at the two free ends. These two free ends. Free ends means there is no other inducing plate on the sides. So these two are free ends, means 1 and 4 are free ends. Look at the free ends, Nana. The charges are equal and their signs also equal. Okay, this is one shortcut. And number 2, look at these two, Nana, opposite ends. Okay, these 2 and 3. They are also having the same charge, but they are unlike. One is plus, other is minus. So these two shortcuts you have to remember further to solve the numerical standard. The free ends have same charge, same sign, but the opposite ends have same charge, but the signs are unlike. Okay, one is like, other is, sorry, one is plus, other is minus. Okay, remember them as a shortcuts, Nana. Okay, and here today's class I'm winding up, right?